Today I'm just talking about a project that we've done funded by ACARP related to dust control again. Obviously still a pretty big issue for the industry, and this presentation is obviously delivered by me, but we've got quite a big team of people who worked on this presentation, so it's not all just work by me. We have heard today from a number of speakers about dust being a continued issue in the industry, so I don't think I need to emphasise that anymore. We're continuing to have exceedances, so it's still something that we need to work on and we need to improve. And so the work that presenting today and that we've been working on is how we can improve the education of our workers to sort of make sure they have the best understanding and the best attitudes to try and reduce these exceedances occurring. And so the aim of this project was to develop an immersive simulation tool for visualising dust in gate road development panels, just as a kind of an example of the technology that we have available to us and what we can kind of achieve with that. And from that, we're aiming to develop an educational platform, as I say, trying to develop a better way that we can educate our workers so that actually will sink in to the workers. That'll be inherent in them when they're on the job, they're doing their work, they will be able to have these experiences from this platform and use that to make informed decisions when they are doing the job. Ultimately by having a greater understanding of dust mitigation and control. So this project was funded by ACARP, and it was a really multidisciplinary project. Obviously, I'm a mechanical engineer, as Justin mentioned. We're working in the mining industry, and we're trying to do work using virtual reality. So we had to have virtual reality developers and computer scientists, and we're trying to monitor dust, so we had to have occupational hygienists. So we kind of got a team together covering all these areas, and particularly we collaborated with coal services with the huge amount of talent and data that they had available, so that we could bring all that together to deliver this project. The end idea of the project was to have a headset-based 360-degree learning environment that we could put our workers in. They could have the sights, sound, experiences as close as we could feasibly make with today's technology in this virtual reality headset environment, as you can see this sort of layout here. And so the big thing out of that is when we talk about dust and educating our workforce, often what traditionally it has been, well, from my perspective, I've written a lot of papers and that kind of stuff, but no workers are ever reading any of that kind of thing. And there's a lot of 2D images and maybe videos showing why dust occurs and what's contributing to that. But to actually experience that around you and be able to see the dust that might normally be invisible to you, and to have some confidence that what we're presenting there comes from real physical data and has been developed based on that data and real science, hopefully gives the workers confidence that what they're seeing and the experiences that they're getting around them in this virtual environment is real, and they can take that as a proper educational experience. And so the difference with that compared to sort of a lot of the other virtual reality systems that you may have or may not have experienced in the past, many of these existing systems are based on like approximations, game engines, so just like shooting some water out or shooting some dust cloud out, and it's not necessarily replicating the real world. And so that was a really big focus for us, that we really wanted to replicate what was actually happening, so that when we use this as a tool, we are teaching the right things. In order to do that, we needed to base everything we were doing. All of it needed to be in a foundation of real data. And so we were really fortunate to be partnered with coal services and have access to their historical data and use that to inform the decisions we were making. So one of the first things that we did was to go through and have a look at previous monitoring that had been done and have a look at what were the factors contributing to the exceedances that are already occurring. And so from that, we identified the top three. And the top three are really interesting for us from an educational perspective, because the first one is cutting stone, and that's sort of something that we can't really control. If you have to cut stone, you have to cut it. You can't really do much about that. And we know the reason why that's a big problem with exceedance is because we have such tight regulations, and when you're cutting stone, it's often dry and generating a lot of dust. The second one, operator positioning, is essentially an administration control. So it is something that we can definitely we can educate our workers on and tell them or show them where the best places to position and where they don't want to be positioned. And so that's something we can definitely solve. And then the third one is an engineering control. So as engineers, we can make sure that we're using the best arrangements, the best control methodologies, best technologies, and make sure that we're educating the workers, people at the coalface, on how those technologies work, why they work, and what it looks like when they're not working. So that sort of framed our project and what our goals were in terms of what we wanted to put in this virtual reality environment. And then we come up with a list of sort of scenarios to try and demonstrate to the industry what this technology can do and where we can potentially take it from here. So with that in mind, we generated a total of sort of 12 scenarios to put into this virtual reality environment. The three main sort of sections I've listed there were just looking at, when you are cutting coal, what happens with your control systems in terms of the mine that we're working with had a externally mounted vent duct for their continuous miners. What happens where you're maintaining the position of that relative to the face, and what happens when you're not maintaining the position of that relative to the face. The next one, of course, was what is the impact of cutting stone. If we simulate that, what's occurring and why is that occurring? Similarly, how does it change with our engineering control? And then the third one there being what happens as we move away from our fan and we get greater pressure drops and we start reducing our ventilation rates, or our ventilation rates drop over time regardless. And then we did a few more based on feedback we got from industry, things like during breakaway, holing through, or if you actually have a ventilation failure altogether. So we had the top level sort of data from coal services in terms of this is where the exceedances were occurring, but to actually do this properly we needed real-time data on a continuous miner to be able to map the profile of dust concentrations over that continuous miner during operations. So the way we did that is we nominated 6 locations you can see here on the miner so that we could actually detect the dust across the miner and understand what is happening over time. By measuring at each of those 6 locations, we fitted 3 dust monitors. So we had a AM520, light-based real-time monitor, a PDM 3700 mass-based real-time monitor, and then just your standard gravimetric dust monitors. And so from them we could get our coal dust and silica detections. So we went through and we did a series of sampling on multiple days. So across 3 days we were able to get this whole range of sampling. You can see here we had some problems with reliability on the PDM 3700, so we weren't able to get as much dust data from them. But in the end we were able to get more than enough data to develop our models from. And in addition to that, we were collecting a lot of photos, videos, observations. So again, as we try and develop this system, we can make sure that it is realistic to what we were seeing in the real world. So from that data, we then need to develop our model and calibrate, validate our model to make sure, again, that we are replicating what's happening in the real world. And so you can see the results of that over here. Where at each of those 6 locations we were able to pick up what the peak dust concentrations are. And so when you look at these numbers, you'd probably be potentially a little bit alarmed if you've never seen real-time data. And the peak concentrations that we do measure are well and above what is actually a shift limit that you'd be used to, your 1.5s or your 0.05 milligrams per cubic metre. So our peak concentrations are very high, and we can see what the distribution of those is over our miner. And then what you've got here is in the green, you've got our simulated model, and in the yellow, you've got the actual monitoring data that we picked up. So we worked really hard to make sure that we could get a match. And the way that we ended up doing that through sort of consultation with the industry and with the data is we found that many of the existing models are just releasing dust from the coal face where, logically you would think it would be released from. But through our observations, discussions and data, we're actually able to identify that, well, the dust is actually coming from a whole number of locations, and we have to make sure that our model is incorporating that. So dust released from the floor in front of the plough on the conveyor as you load into the shuttle car to make sure all of that was included in the model and goes into that virtual reality environment. So this is what some of our simulation models look like. So this is just a standard model. This is the arrangement they had at this particular mine. This is cutting at the floor, and this is how the dust is distributed. So you can see the videos are really nice. You can see what's happening with the concentrations. You can see the concentrations are high. One thing to note is anyone who's been on a continuous miner, you can see the dust, when it's generated when you're cutting, and that is that thick red orange bit at really high concentrations. But the blue sections are relatively low concentrations from an instantaneous perspective, less than 10, and this is the respirable dust that you probably can't see. And this is what we want to communicate to our workers, that there's all this respirable dust around you that you might not necessarily realise that is being generated. And then taking that into some of the different scenarios that we looked through here. So this slide shows 6 or 8 of the different scenarios we looked at here. So on the left-hand side, you have different ventilation rates. And so as you would expect, as you increase the ventilation rates, so from going from the top to the bottom, the area, that yellow area, reduces, and that's at the breathing zone with a concentration above a certain number. And so higher ventilation rate, of course, means that we can hold the dust or control the dust better. We can hold it and guide it into the vent tube much more quickly. And similarly on the right, sort of in the opposite direction, the distance of the vent tube to the face, as you would imagine, as you move it closer, maintaining a good ventilation rate, you can actually capture that dust at the source as quick as possible and reduce its spread around. So fairly logical things, but again, if you're to give this to your workers, they're not necessarily going to sort of look at that and that necessarily sink in and make logical decisions when they're sort of working on the day. So we want to develop a more immersive tool. This one, an interesting one, just to show you what actually does potentially happen if there is a failure in your ventilation system. So this is showing the ventilation system working, and then for whatever reason, the fan might cut out. And at that point, you see sort of a catastrophic dispersion of dust occurring. And so, this is the kind of thing that in the real world, you'd obviously never want your workers to be in place, put in. But in the virtual world, we could actually put them in this situation so they could sort of see what that might look like and what might be occurring around them if that was to happen, just to emphasise the need to get themselves out of that sort of a situation. So from this point, we needed to then try and get this into this immersive tool that we're talking about, this virtual reality tool. And so this was quite a challenge. So these CFD models that we had generated them for a whole bunch of different scenarios, so 12 scenarios that I said, and we needed to process that data and bring it over into a virtual reality environment so somebody could put a headset on and see what's going on. And so data processing became a challenge. The big reason for that is just purely the amount of data that these simulation models take. So to run one of these simulation models maybe takes 2 or 3 days, and they generate 200 gig of data per scenario. And so a little headset that has the equivalent of your phone in it is not going to be able to simulate and show you a video of that moving all around you in real time. And so we needed to work with the computer scientists to get them to actually process that data down to a point where it could actually fit on these headsets, where they've only got 10 gig of data they've only got 6 gig of RAM in total and 64 gig of RAM of data memory, something like that. So I won't spend too much time on this because it's probably not a huge interest to you actually what happened, but basically we went through a process of filtering the data and clustering it so that we could maintain the accuracy of it without actually not needing so many data points. As you might have seen on the previous slide, we had 3 million data points per frame, if you would imagine it as like a video per frame, and so we wanted to reduce that down to something a lot more manageable. This is what it looked like. So the example on the left there is the raw data, and the example on the right is the filtered data. So The sort of overall form and shape looks pretty much the same, but basically the density of the data points reduces through this method that the computer science guys, the sampling method they were able to come up with. And through that, quite amazingly, they were able to reduce our 200 gigabytes from our simulations down to a 60 megabyte total data set for each scenario. It took 20 hours to process all that data, but then once it's processed down to that size, we're able to put it on these headsets so that somebody could put it on and go through a self-guided tour of a development panel and have the dust moving around and everything happen in real time. So hopefully I got some videos of what this looks like. Okay, so on the right here is a video of what our platform then ended up looking like, and we set this up to have two different environments. One environment was a desktop version, like what you can see here, and so in that environment you can see the dust flowing around you, you can see the ventilation flowing around you, you can see what those patterns look like as a result of whatever scenario or arrangement you're working in. And then hopefully in a moment, the other option is actually go inside the mine and have the ability to see that all happening around you, turn around, walk around, move around the mine, stand in different positions and see how that all works, which is what you can see occurring now. In addition to that, because we wanted to turn it into an education platform, we've sort of been working with Coal Services on that for how we can best set that up. And so what we have at the moment is a bit like a self-guided tour where they're able to put the headsets on and there'll be a voiceover kind of talking the user through what's occurring. So they'll explain what the scenario is, they'll tell them, if they want to stand in different places or they can re-watch the scenario however they wish. And then at the end of each scenario, there's some questions that they can be asked to see whether they've actually understood what's occurred and what the learning outcome of that is. And so we've been trying to work with industry to show the technology, gain feedback, and we're still sort of trying to develop it and improve it as we go. But yeah, sorry, a bit loud, but the reaction is, quite visceral. Like they really, feel like they're there when you're trying it out. So it's a really great experience if you've never used these type of technology before, and to actually see dust around you or see ventilation around you that you obviously can't do in the real world. So now that we've developed this process, so we essentially have a process now where we can go through, we can collect the data, we can run the simulations, we can then process that data and generate it into this virtual reality platform. It's now something that we can replicate for different scenarios, or we can generate additional scenarios for our current application, or move it to other applications or even other industries. So it's something that we're hoping we can expand out and develop into a sort of a bit more fully featured tool as a bit of an educational platform in regards to dust to improve the situation. And as we know, it's something that education is very much key to solving. All right, and that pretty much finishes up. So in summary, we've done CFD, or computational fluid dynamics. We've developed our model. We've been able to implement it in this mobile platform. We can actually take this to the mine site, so we can get a dozen of them. They're pretty cheap units, like maybe $500 each. You can take them to the mine site, have the software loaded on. The workers can go through that education platform, get an understanding about it, and then hopefully that improves the decision making when they are underground being exposed to these situations. If you do want to read more about this, we generated an ACARP report, as is always the case, 100 and whatever pages, if you're really keen. Otherwise, if you just want some information, videos, or if you want to try it out, feel free to email myself, or a lot of you probably know Jennifer Hines, who was supposed to give this presentation, Professor Ting Ren, or Coal Services. Any of us will be able to help you out. And that's it. Thank you very much.